All right, this is October, November 18, paper 21. Now, iron pyrite has a yellow color that makes it look like gold. It contains the Fe2 plus and S2 2 minus ion. Okay, give the full electronic configuration of Fe2 plus. So you go to the data booklet, to the periodic table, and we see that iron is right here, right? So it's 3D 1, 2, 3, 4, 5, 6. So iron की जो configuration होती है वो क्या होती है? 3D6 4s2. So iron जो है it is 1s2. It ends with 3D6 4s2. Right? Now we know Fe2 plus में कौन से दो electron remove होंगे? The S वाले electrons are removed first, right? Yes. So we remove this, so the Fe2 plus is just 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d6. The 4s2 have been removed. Calculate the oxidation number of sulfur in the S2 2 minus ion. Yes, Maria, thank you. What's the average oxidation number of sulfur? भाई दो sulfur atom है और उनका overall oxidation number -2 because that's the charge, right? So that means each sulfur atom has an oxidation number of -1. So that's just -1. Describe the metallic bonding in gold. Describe the metallic bonding in gold. How do we describe metallic bonding? Delocalized electrons, right? So metallic bonds में क्या होता है? You have this, right? You basically have sort of cations held by a sea of delocalized electrons. So on, right? You don't have to draw it. I'm drawing it as a. Right, this is what it looks like. So you have negatively charged electrons that are sort of holding the metal cations together. So metallic bonding can be. Huh? But nahin, line space इसीलिए दी हुई है ना. But you have to basically say that they are electrostatic forces of attraction. Yes, between cations and delocalized electrons. And yes, if you do draw a diagram, you'll still get the marks. Generally speaking, for these. So it's okay to draw the diagram as well. All right. Iron pyrite is often called fool's gold because of its appearance. Impure sample of iron pyrite often contain a small amount of gold. The gold can be obtained from this impure iron pyrite. The iron pyrite is roasted in oxygen to produce iron 3 oxide and sulfur dioxide. Gold does not react with oxygen. The sulfur dioxide produced would cause environmental consequences if released into the atmosphere. State and explain one of these environmental consequences. Acid rain, yes. Okay, so it causes acid rain. And one consequence of this. Corrodes buildings, yes, you can say lowers pH, kills wildlife, fish, oceans. No. Acidity से cancer नहीं होता. Acidity से cancer नहीं होता. वो दूसरे pollutants होते हैं जिससे cancer होता है. Okay. So it causes acid rain. Okay. And what this does is it does many things, right? One consequence is that it, or we can just, I don't have to say one consequence. It lowers the pH of the soil. making it difficult for plants to grow, right? Write an equation for this reaction. Well, this one's pretty straightforward, right? They've said iron 3 oxide, sulfur dioxide and oxygen, right? So oxygen के साथ react करता है, oxygen के साथ react करता है to form sulfur dioxide and iron 3 oxide, right? And they've been kind enough to balance everything for us. We have 2 times 4, 8 sulfurs, so that becomes 8 SO2. And then oxygens कितने हैं यहाँ पर 6 plus 16, 22. So we're gonna have 11 O2. Okay. A sample of impure iron pyrite was roasted on oxygen. The composition of the solid mixture of solid products is shown. Calculate the mass of iron pyrite present in the sample of impure iron pyrite. So they've told us कि भाई ऑक्सीजन की रोस्टिंग के बाद हमारे पास इतना आयरन 3 ऑक्साइड बना था, तो आयरन पायराइट कितना प्रेजेंट है ओरिजिनल सैंपल में? How do we do this?
Moles of Fe2O3.
So yes, the first thing you would do is you find the moles of Fe2O3. And they've been again kind enough to give us the MR or the formula mass. The number of moles is the mass, which is 33.18 divided by the molar mass, which is 159.6. 0.208 moles of iron pyrite, of iron 3 oxide, sorry. Now what do we do next? 20789. So let's actually, since we want the answer in 3 significant figures, let's do our working in 4. So 2079 moles, right? Next we have number of moles of FeS2, right? Now we know that for every 2 moles of iron 3 oxide, we have 4 moles of FeS2. So we just have number of moles of FeS2 is just twice as many. 2 times 0.2079, which is 0.4158, right? Moles. So this is how many moles we have, right? Again, if you guys, I'll just write this down. We know that FeS2 to Fe2O3 is 4:2. So 2:1. Okay. So we just have twice as many moles of this. And now the last thing we have to do is find the mass, right? We know the number of moles is the mass over the molar mass. 4158 times the molar mass, 120. And that's equal to the mass. So क्या आ रहा है mass? 49.9. So the mass comes out to 49.9 grams. Yeah, the 49.89 grams. So that's 3 significant figures. That's 49. Although I would report it 2 decimal places here. Why am I reporting it to 2 decimal places? Look at the information given in the question. Mass is just precision में दिया है, see? So it's better to report it like that. 899. 96 are. सही. Yeah, it's okay. 49.9 भी accept कर लेंगे. ये physics की तरह नहीं है कि आप मतलब हमें सही है ना, इनके वो नखरे नहीं सही. Use your answer to part 3 to calculate the percentage by mass of gold in the sample. Okay, give your answer to 2 significant figures. Now we know the mass of FeS2, right? And they've told us products में हमारे पास gold इतना है, reactants में कितना था? Unchanged होगा ना, it doesn't react with oxygen. तो जितना gold शुरू में था उतना end में था, one reacted rather throughout. So we have the mass of gold and we have the mass of iron pyrite. Impure sample में we have gold and iron pyrite. So the percentage of gold is the mass of gold I'll write this down. The mass of gold we have is 0.37 grams. And the mass of FeS2 that we have is 49.89. So the percentage of gold is 0.37 divided by the total mass. Right? Times 100. What does that come out? 0.74. Yes, to two significant figures. So 0.74%. So that's the percentage by mass of gold. इस दफा बच गए. इस दफा. Explain why nitrogen is inert. So that's one reason, right? What's the other reason? Needs a, so yes, so nitrogen, high energy needed, yes. So nitrogen has a strong triple bond, right? Hence a high amount of energy is needed to break it. Ugh, stupid question. I hate this question. Nitrogen molecule. अच्छा नाइट्रोजन मॉलिक्यूल बना लेना बस. ट्रिपल बॉन्ड है, एक बॉन्ड, दो बॉन्ड, तीन बॉन्ड. Nitrogen has 5 outer electrons. 3 of them are in the bond and then 2 of them are unbonded. Nitrogen and oxygen react together in the air during lightning strikes to form nitrogen monoxide. Explain why it occurs during lightning strikes. Activation energy, yes. So this is this has to do with the fact that lightning produces a lot of heat, right? So it provides enough activation energy to make nitrogen react, right? Yes, thank you, Mohammed. Why did you add it in the denominator, Mohammed? The gold ka mass? Because the percentage is like the mass of gold over the total mass. Na? The impure sample has gold and iron pyrite. Make sense? That's why we added gold ka mass. Lightning provides high enough activation energy. Write 2 equations to suggest how the NO formed reacts further to create nitric acid. So nitric acid बनाने के लिए पहले क्या बनेगा? Yes, so पहले nitrogen monoxide बनाएगा, nitrogen dioxide, then it reacts with water to form nitric acid. Oh wait, sorry, yes. Something wrong. Yeah. Nitrogen dioxide, nitric acid कैसे बनाते हैं? मैंने SO3 वाला लिख दिया था. अच्छा पहले मुझे ये बताएं, नाइट्रिक एसिड में you have HNO3, right? इसमें ऑक्सीडेशन स्टेट क्या होता है नाइट्रोजन का? +5 होता है, right? Hydrogen is +1, oxygen is -6, so nitrogen is +5. और नाइट्रोजन डाइऑक्साइड में क्या होता है? +4 होता है. So it's actually a redox reaction. It's actually a redox reaction. What you have is you have water, but water के reaction के साथ oxidation नहीं होती. You also have more oxygen reacting with it. Okay. So this is the equation for the formation of nitric acid. Nitrogen dioxide reacts with water in the presence of oxygen to form पहले से balance कर दिया to form nitric acid. Now let's balance this, right? Now we know how many, we have two of these, right? Because we have two hydrogens. We're gonna have two NO2. And then how many oxygens will we have? 4 plus 5. यहाँ पर 6. So we're gonna have half. So that's the balanced equation. So if you guys want to write this down, write down this equation. This equation is for the formation of nitric acid. Yes, sulfur का जो होता है उसका straightforward equation है. Sulfur trioxide just reacts with water to form sulfuric acid. मैंने वो दोनों mix कर दिए सही. This one is straightforward, but for nitrogen we are also oxidizing it. This one is not a redox reaction. ये वाला redox नहीं होता, ये वाला redox होता है. Nitrate fertilizers are used to provide nitrogen for plant growth. Uncontrolled use of these can cause a reduction in animal and plant life and natural water supplies. Explain how uncontrolled use of nitrogen fertilizers. Yes. So how does this happen though? How does this cause this problem? If I have too much nitrate fertilizer, what happens?
Washes away into the
Yes.
uncontrolled use of that.
Nitrates are washed away, okay, into bodies of water, right? Right. Nitrates are washed away into rivers, right? What happens? This promotes, right, the growth of what? Algae. Right? And then what do? They block sunlight, which blocks sunlight from getting to, oh my god, this reminds me of O-level bio, from getting to aquatic organisms. Okay, what else happens? Yeah. Okay, so for aquatic organisms, so more specifically aquatic plants, right, which can no longer photosynthesize, which do not. Yes, yes. Hey, what if people don't know this? It's possible, right? And then bacteria decompose. Does everyone remember this? Bacteria decompose these organisms, right? Consuming oxygen, right? Causing aquatic organisms to die. For those of you who are interested, it's because they can't respire anymore. Okay. Some soils have compounds such as ammonium nitrate, calcium carbonate, and calcium hydroxide. Suggest why calcium hydroxide is added to some soils. Well, not necessarily. To reduce acidity or just to increase pH. Maybe you want an alkaline soil as well, no? Rather than neutralize it. But the key idea here is that so that is correct. But to increase pH is essentially the reason. Food for fish is no more, Roha says. Very well, very eloquent. Food no more. So when it reacts with ammonium ion, the gas is produced. What is the identity of the gas? Yes, when ammonium and hydroxide react, ammonium will act as a proton donor, right? It will donate that proton to the hydroxide to form NH3 plus H2. It's a neutralization reaction. Ammonium is a weak acid and hydroxide is a base. So we can say that the gas is ammonia. Okay. And suggest why the reaction occurs. Why does the reaction occur? Because the NH4 plus donates a proton to OH minus, right? Since it's a weak acid. Acts as a Bronsted-Lowry. I won't write the full name. Bronsted-Lowry acid. Okay. Another fertilizer, calcium ammonium nitrate, is formed when solid calcium carbonate is added to a mixture of aqueous ammonium nitrate and dilute nitric acid. State what would be observed in this reaction. Yes, so what will you observe? Carbonate, metal carbonate with acid, bubbles of a colorless gas, and the solid dissolves, right? Calcium carbonate will dissolve and carbon dioxide will effervesce, right? So you will see effervescence. I hate this word. I'm going to say bubbles. मतलब फालतू में जिंदगी मुश्किल की है ना, bubbles of colorless gas. Part 2 में explain why the reaction occurs. Because NH4 plus acts as an acid, right? A Bronsted-Lowry acid. So it's a proton donor. So it donates a proton to OH minus. Yeah. So calcium hydroxide is hydroxide. No? Calcium the spectator है ना. It's really hydroxide. हाँ, hydroxide लो या calcium hydroxide लो दोनों correct है. Basically, it's the hydroxide that's reacting. So bubbles of a colorless gas are observed, right? And the solid dissolves. Calcium nitrate decomposes at a higher temperature than calcium ammonium nitrate. Right? Huh? Write an equation for the decomposition of calcium nitrate. What does it form? Calcium nitrate. Calcium oxide, nitrogen dioxide, and oxygen. Now we have 2NO2. So the remaining half O2. Or if you want whole numbers, you can do that as well. The both fine. That was half the paper, really. Question number 3. Trihalomethane are organic molecules in which 3 of the hydrogen atoms are in methane are replaced by halogen atoms. So trichloromethane is a trihalomethane. Okay. Explain what is CHCl3, the liquid with high vapor pressure. Explain what is meant by the term high vapor pressure. The vapor pressure. So a simple way to understand vapor pressure is basically like, so if you think about atmospheric pressure, right? Like your vapor pressure is basically the pressure that is, it's essentially atmospheric pressure and vapor pressure are in equilibrium at the boiling point. What does that mean? That means that you can think of vapor pressure as the tendency of the liquid to turn into gas. Okay, that's one way to think about it. All right. So as I'm boiling, right, what happens is that the vapor pressure is increasing. Okay. And above the boiling point, the vapor pressure will be greater than the atmospheric pressure. So the liquid will evaporate. Okay. Something that has high vapor pressure is considered to be volatile. Right? Because it wants to convert into vapor more. Okay. All right, so what we have over here is, so what we can say over here is by high vapor pressure, we can say right? We say that the gas particles, okay, are in equilibrium with liquid particles. And this is actually why high altitudes for the boiling point decreases, because there's lesser atmospheric pressure. So that means lesser energy is needed for the liquid to turn into gas. Because नहीं, ठंड की वजह से नहीं होता. It's because density of air is lesser up there ना, तो pressure कम होता है, volume कम होती है ना हवा की. हाँ एग्जैक्टली. अगर बेसिकली आप पानी को कम दबा रहे हो, इसका मतलब पानी आराम ज्यादा आसानी से बाहर निकल सकता है. ओके, so gas particles are in equilibrium with liquid particles, right? But if we have high vapor pressure, that means this equilibrium lies towards the gas particles more. Okay, okay. More liquid particles are more, sorry, there are more gas particles present than liquid particles. Now you might say, यार ये equilibrium है तो फिर evaporate क्यों करता है? Because if you think of it this way, अगर liquid पड़ा हुआ है, वो liquid और gas equilibrium में, लेकिन वो gas हवा से चलो गायब हो गया. अगर आपने कंटेनर बंद किया हुआ है तो क्या होगा? Equilibrium होगा. So let me sort of demonstrate this. Since this is a concept, ideal gases में क्या था, बहुत shortly क्या था, तो I'll explain this to you guys. Let's say I have a lid over here, okay, and in this jar over here, what I have is let's say bromine liquid, right? Now some of these particles are converting to gas, some of these particles are converting to liquid, right? So there's this equilibrium, liquid to gas and gas to liquid, right? Now if I lift the lid off, then the gas particles get blown away. So then more liquid is converted to gas. If I lift the lid off, the gas particles just diffuse away, right? So then more and more liquid is being converted to gas. I keep on shifting the equilibrium towards the gas particles. हाँ, तो इसके अब eventually फिर क्या होगा? Okay, नहीं तो इसके eventually क्या होगा कि eventually all the liquid will evaporate as liquid keeps on converting to gas. For more volatile liquids, there's more gas particles present than liquid particles at this equilibrium, which means that they'll evaporate faster than less volatile liquids. Okay, so more gas particles present than liquid particles at equilibrium.
So it converts from liquid to vapor when it is in equilibrium.
In equilibrium, liquid to vapor भी हो रहा है, vapor to liquid भी हो रहा है. अगर मैंने अगर हवा, let's say मैंने lid हटा दिया, तो the gas will get blown away, right? And if the gas gets blown away, what will happen to the equilibrium? It will shift towards gas, right? अब जो ज्यादा volatile चीज है, उसमें ज्यादा gas बन गई है. For every molecule of liquid, more gas is being made essentially. So the so it shifts faster to the right, it evaporates faster. So that would mean by high vapor pressure. Okay. So in this equilibrium, obviously, जितने ज्यादा gas molecules होंगे equilibrium पे, उतना ज्यादा pressure होगा in the closed container, which you see here. Okay, that's the idea. Yeah, this concept very, very rarely shows up, but that's why this is actually only this part is why I chose this paper, was to go over this concept with everyone when half the class that is present today. Now, an important reaction of CHCl3 is the manufacture of CHClF2 using the following reversible reaction. Use the data to calculate the enthalpy change of the reaction delta H for the formation of CHClF2 as shown in the equation. So we had to find this enthalpy change for the forward reaction, right? And they've given us the enthalpy changes of formation. Yes, you don't even have to draw a Hess cycle. You can, but we know that the delta H for any given reactions, they haven't asked you to draw an energy cycle. We just know that this is the formation of products minus the formation of reactants. अब products हमारे क्या हैं? CHClF2, which is minus 482.2, 2HCl, so we're gonna have 2 times minus 92.3, right? And then minus the formation of CHCl3, which is minus 103.2, and minus the formation 2 times the formation of HF, so minus 2 times minus 273.3. So this comes out to minus 17.0 kilojoules per. The reaction in part 2 is carried out using a heterogeneous catalyst. Explain fully the meaning of the terms heterogeneous and catalyst. What do we mean by heterogeneous? In a so in a different phase or different state from the reactants, right? Heterogeneous means in a different state. Than the reactants. And what do we mean by catalyst? Yes, my thing. Catalyst का मतलब क्या होता है? So the substance that increases the rate or speeds up of a chemical reaction by reducing the activation energy, yes. But what else does it does? Yes. By providing an alternative pathway or alternative mechanism. Pathway with lower activation energy. Okay. It itself is not used up at the end of the reaction. CHClF2 was used as an alternative to chlorofluorocarbons. CHClF2 should no longer be used because it was found to contribute to the enhanced greenhouse effect. Give the meaning of the term enhanced greenhouse effect. No. Greenhouse effect क्या होता है? हाँ, basically greenhouse gases होती हैं, so they trap heat and they lead to the atmosphere being warm, right? And greenhouse effect is necessary for life to a certain extent. Naturally, greenhouse effect is a natural phenomenon. Enhanced greenhouse effect क्या होता है? Yes. So you have to say that it's caused by human activity. Okay. The word enhanced over here is due to the fact that because of unnatural activity or human activity, we have more infrared gases present than we should. Okay. Or more greenhouse gases present than we should. Yes. So that's why they've put in italics the term enhanced greenhouse effect, not greenhouse effect. So it's basically the exact same thing, but you will also say you have to mention that it's because of human activity. So enhanced greenhouse effect is that, right? The increase in greenhouse gases due to human activity, right? Causing global temperatures to rise. Explain how CHClF2 might contribute to this effect? How may it contribute to this effect? Because it will absorb heat, it will trap heat, it'll be able to absorb infrared radiation. So how it may, like you literally have to explain how any greenhouse gas works. So how CO2 may, how this guy may, or anyone, right? So it would trap heat, right? Right, in the atmosphere, okay, resulting in an increase in global warming. Okay. Suggest another environmental problem associated with this. Ozone layer depletion. Remember, halogenoalkanes mein chlorine radicals hote hain, they react with ozone, right? So another environmental problem is depletion of ozone. Okay. CHClF2 is also used to produce the monomer tetrafluoroethylene. This monomer can be used to produce polytetrafluoroethylene, which is PTFE. State the type of polymerization. Addition polymerization. Okay. What's the repeat unit of PTFE look like? Well, we know that the alkene is just this, right? This is the alkene. So the repeat unit will look pretty much the same, but it'll have the continuation bonds. Suggest why PTFE is used for coating pans. How on earth is this a one? Why have they given 4 lines for this? This is deception. It's like a 1-word, 2-word answer. It's non-sticky. Like you're giving me a qualitative thing. Like give me a more chemical thing. You said, what did you say? High. So, agar temperature zyada, so what does that make the molecule itself? Unreactive. Exactly. So it is unreactive. That is the answer. ये बोल रहा हूँ ना, और मुझे लग रहा है यहाँ पर बंदा पूरा मतलब वो हाँ yes it dot is reacted exclamation mark. Then it says state 2 other difficulties associated with its disposal. So waste disposal can cause litter problems. Yani ke aludgi, right? So what are 2 other difficulties? Yeah, so it's an addition polymer, so it doesn't degrade, so it's non-biodegradable. We'll actually learn about degradable polymers in A2. So it's non-biodegradable. And what's the other thing? Huh? क्या कह रहा? Don't be distracted. Yeah. What is it? Acha, why can't it be burnt like other hydrocarbons? Why can't it be combusted like other hydrocarbons? It can still be combusted. It's unreactive doesn't mean it won't react. It means कि fan के temperature पे reactive नहीं, लेकिन उससे ऊंचे temperature पे हो भी सकता है. Right. इसके अंदर फ्लोरीन प्रेजेंट है. या आप लोगों को पता नहीं अगर याद है कि नहीं याद है, लेकिन हमने बात की थी कि जब हैलोजेनो एल्केन्स को कंबस्ट करते हैं तो HF या HCl बनती है. जब आप कंबस्ट करते हो एसिडिक गैसेस बनती हैं. These are very strong acids. So, right, So yes, combustion produces harmful gases. Tens of thousands of years. Yeah. Lovely. In it. So we have example HF, and then obviously you also have the regular combustion products such as carbon monoxide, but you also have HF and HCl in the case of fluoroalkenes being produced. Question number 4. The structure of glycolic acid is shown. Complete the table to show what you would observe when an aqueous solution of glycolic acid is added separately to each of the reagents. If a reaction occurs, state the functional group of glycolic acid that is responsible for the reaction. Sodium carbonate के साथ क्या करेगा? Effervescence of a cup. So I'll just say bubbling again because I hate that word, bubbling. So does a reaction occur? Obviously it does. And what's the functional group that reacts with it? Who's calling me right now? Group react करती है कोई? कौन सी functional group react करती है? Sodium carbonate के साथ carboxylic acid. Yes, COOH. Yes, वो भी लिख सकते हैं. 2,4-DNPH. You will say no reaction. Please say no reaction. People leave it blank, they don't get the mark. Just
Does the reaction occur to cross लगाना?
हाँ
No reaction की जरूरत नहीं.
हाँ क्रॉस लगा लो, खाली नहीं छोड़ना, मैं ये बोल रहा हूँ. उनको दिखा देना कि आपको पता है कुछ नहीं होता है यहाँ पे. मेरा बोलने का मकसद ये है, समझे? ओके. डज अ रिएक्शन अकर? यहाँ पर भी लिखना दे. ओके, यहाँ पर कुछ नहीं लिखना. Acidified dichromate 6 with glycolic acid. So primary alcohol. So what's the observation? Dichromate के साथ क्या होता है?
Orange to
Green.
green.
It's oxidation of primary alcohols, right? So solution goes from orange to green. Obviously a reaction is occurring. And what group is reacting? If someone says alcohol, now I'm going to kill them. You will say primary alcohol. Okay. Two reaction sequences to make glycolic acid are shown. In the first sequence, what we do is we take this aldehyde HCHO and add HCN to it in the presence of NaCN. So draw the structure of X. So addition of HCN. So पहले हमारे पास था hydroxynitrile बनेगा ना. We had methanol, right? This is what we had, and what we've done is we've added HCN. This is nucleophilic addition, if you guys remember. So what we've done is we've done this. It's a different color. So that's what we've done. Addition of HCN to. Huh?
What will be the name for this?
This is methane nitrile, right? Hydroxymethane nitrile. One carbon and no, hydroxyethane nitrile. Was 2 carbons, right? Ethane nitrile, yes. Hydroxyethane nitrile. Name the reagent for reaction 2. Reaction 2, we're converting the nitrile to a carboxylic acid.
Dilute.
Yes, so you said dilute HCl, right? So the second reaction 2, may use. Name the reagent. Name it. So you will just say that the name of the reagent is just hydrochloric acid. The conditions may would be dilute, reagents and conditions. But the mechanism of this reaction for reaction 3. Reaction 3 में क्या हो रहा है? Carboxylic acid is remaining a carboxylic acid, but one of the hydrogen atoms is being replaced by a bromine. कौन सी? Nucleophilic. Saturated alkyl group पे ब्रोमीन लग रहा है. हाइड्रोजन इज बीइंग रिप्लेस्ड बाय ब्रोमीन. हाइड्रोजन कौन सी मैकेनिज्म में रिप्लेस होता है? It's not nucleophile being replaced. Nucleophilic substitution में क्या होता है? OH will replace Br या Br will replace OH. Right? Nucleophile is being replaced by another nucleophile. Delta positive होता है carbon. यहाँ पर hydrogen is being replaced in a saturated compound. Free radical substitution. Alkanes में जो होती है. Hydrogen is being replaced in a saturated compound, right? Yes. Yes, thank you, Mohammed. That is indeed the answer. So what we have here is free radical substitution. Suggest the essential condition for this reaction, UV light. Yes. Reaction 4 occurs via an SN2 mechanism. SN2 is a, how many steps? One step. Occurs via, yes, one step. Via an SN2. Complete the diagram for the mechanism, include all, everything. So what we have here is we have a delta positive carbon, delta minus bromine. We have this guy over here, right? And what it does is it sort of attacks. कहाँ बना के दिया हुआ है? मैंने मुंह ना तोड़ूं, मेरे को देखो तो सही कैसी हरकत है इनकी. मतलब थियरी में क्या सिखाते हैं? Oh, you should know that the OH attacks from the side opposite the Br. Now look at where they've drawn it. मतलब like कसम से ऐसे बनाओ. There attacks from the back and this bond breaks at the same time. Okay, that looks about right. But I mean, even if you draw it like this, guys, it'll be fine. I'm just being a pain. So at the same time as the bond is being formed, the bond obviously breaks as well, right? दोनों चीजें साथ होती हैं. Because SN1 में तो आप पहले कार्बोकैटायन बनाते हो ना, तो कार्बोकैटायन is like this. वो यहाँ से भी आ सकता है, यहाँ से भी आ सकता है, like, which is why SN1 में you can produce optical isomers, whereas in SN2 you'll only produce one isomer. Okay. Glycolic acid can be made by reacting glyoxylic acid with NaBH4. This is glyoxylic acid as an aldehyde and an alpha acid, and it's converted to primary alcohol and acid. So what is NaBH4 doing here? Reducing agent. Right. Write an equation to represent this reaction using molecular formulae. Okay, so C2 H2O3 reacts with 2H, that's reduction of aldehydes, okay, to form C2H4O3. Pretty sure I gave this question in a test last year. This.
It was about
Isomers the definition. Mocks में दिया था, that's what Mariam is saying. Yeah. Glycolic acid is heated in the presence of a sulfuric acid catalyst. A new compound Y is formed. The infrared spectrum of Y is shown. अच्छा, पहले बताओ रिएक्शन क्या हो रहा है ग्लाइकोलिक एसिड का यहाँ पर. Glycolic acid, in the presence of concentrated sulfuric acid, this glycolic acid is releasing water. So what type of a reaction? Esterification हो रही है ना, self esterification. Basically हो ये रहा है कि ये मतलब ये this guy over here is forming an ester with this guy over here. या आपस में ही मतलब ये basically इसके साथ तो नहीं, एक दूसरी molecule के साथ glycolic acid की it's forming an ester linkage between these two, right? Now that will release one water. And then this guy over here is also forming an ester with this guy. So we have a diester being formed, right? Basically दो molecules आपस में दो ester linkage बना रही हैं, एक का OH दूसरे acid के साथ, दूसरे का OH पहले के acid के साथ. Okay, so that's what we have here in the presence of concentrated sulfuric acid. Okay, now suggest a structure for Y. So let's actually draw that structure first. Let's actually draw that structure first. What we have is we have a CH2. क्या था हमारा? What's the formula here? CH2OH, CO2H, right? And you have two of these molecules combining. So what happens here is this. We have a C double bond O, OH, right? Now this guy comes from the, so एक second, CO2H. Let me draw this out. We have this guy here, and then you have CH2 and OH. Right, so this is one molecule. अब होता क्या है कि ये जो है एसिड ग्रुप ये बनाती है लिंक किसके साथ? अल्कोहल के साथ दूसरे वाले कंपाउंड की. So you have O, you have CH2, right? So CH2O जिसका था दूसरी जो मॉलिक्यूल है उसका CH2OH ने यहाँ पर एसिड ग्रुप के साथ बना लिया. सिमिलरली ये जो एसिड अल्कोहल है ये दूसरे की एसिड ग्रुप के साथ बनाती है, right? So that's the structure for this compound. Okay. The reason I've shown it like this is because we know that the O comes from the alcohol and the C double bond O comes from the acid in the ester linkage, right? All right. So that's the structure. Now state how this spectrum, the spectrum of this product here differs from an infrared spectrum of glycolic acid. Explain your answer with particular reference to the peaks within the range 1500 to 1400. So what's the key difference? Glycolic acid में क्या present होगा? कौन सी किस bond की peak present होगी glycolic में?
Carboxylation.
हाँ, carboxylic acid का कौन सा bond? C double bond होता है. वो तो दोनों में, वो तो ester में भी है. Remember OH, right? Yes. So the OH bond would be absent in this guy, right? So how would it differ from glycolic acid? So a broad peak at approximately, this is from the data booklet, at approximately 2500 to 3000 wave numbers, right, would be observed due to OH from acid. Okay. And another thing that we have is that we would also see, if you go to the data booklet here, we would see that broad peak, and we would also see a peak at around 3200 to 3600 for the other one, which is the किस चीज की OH? दो OH peaks है ना आपके पास, कहाँ पर है ये? हाँ, एक कार्बोक्सिल वाली OH है और एक अल्कोहल वाली OH है. तो दोनों के आपको पीक्स नजर आएंगी अलग, right? So you have and, right, a peak at approximately 3200 to 3600 wave numbers. Centimeter cube क्यों लिख रहा हूँ? Deep for OH from alcohol. Okay. And this would be, I'll write this down, only glycolic acid would have these, right? Only glycolic acid would have these, not the product that we're forming. How do we figure out the structure? The structure was complex. Okay, so the way to figure it out is this. Okay, what we know is that a CH2OH CO2H is reacting with another one of these guys. It is reacting with another one of these guys. Okay, so I'll write this down for you. So two of them are reacting opposite. How do we know there's two of them reacting? Because they've shown that in the equation. Two of them are reacting to form one compound, and they've also shown that two water molecules are released. We know that for every ester linkage, one water molecule is released. So there must be two ester linkages being formed. Okay. Now, since two ester linkages are being formed, we know for a fact, let's draw this out a little bit more. What we have is, we know for a fact that इसका जो OH है और इसका acid group है, right? And अगर आप ऊपर वाले को देखें, so let's write it down the other way, right? We have an acid group, right? And we have an OH, right? This is what's happening. Now we know for a fact that the OH group loses a hydrogen, right? The OH group loses a hydrogen and the acid group loses an OH. That's one ester linkage. And the other ester linkage, what we have is over here, again, this guy loses a hydrogen and this guy loses an OH. Okay, so these are the two water molecules that are formed. These are the two water molecules that are formed. Wait, so OH लिख देना. Bhai, struggle yaar, huh? So these are the two water molecules that are formed, right? So now what do we have left? What do we have left? So this is what we have left. So you have to figure this out. आपको पता है कि भाई यहाँ पर COCH2O एक मॉलिक्यूल से आएगा, COCH2O, और दूसरा COCH2O दूसरी मॉलिक्यूल से आएगा. Okay, that makes sense.